Lesson 5.3 is function rules, tables, and graphs. So, title your paper, function rules, tables, and graphs with 5.3 at the top. Now, here's the first one. Model the function rule y equals -1/2 x plus 1 using a table of values and a graph. So they might ask you to do this as a problem. So you would have to set up the table. Choose input values for x. Notice they just picked whatever they wanted for x. You can pick any numbers for this. Okay, they picked 3. That's perfect. It doesn't have to be, you don't have to do 17 numbers. Okay, plot the points for the ordered pairs and join the points to form a line. So then it says, A, how would the table and graph of f of x equals -1/2 x plus 1 compare to the table and graph in example 1? So they want to know, how is this different than this? And there is absolutely no difference. They are the exact same. However, they just changed the beginning. This one starts with a y and this starts with the f of x. They're exact same though. So now try this. Model the rule f of x equals 3x plus 4 with a table of values and a graph. So try that problem. Okay, so I am going to do -1, 0, and 1. And then my f of x is this equation, 3x plus 4. So 3 times -1 is -3 plus 4 is 1. 3 times 0 is 0, plus 4 is 4, and 3 times 1 is 3, plus 4 is 7. And then I draw a graph, and I have -1, 1, make a dot, 0, 4, make a dot, and 1, 7. And then I draw my line. It does not have to be perfect. It can be just a sketch like mine. All right, real world problems. Suppose your group recorded a CD. Now you want to copy and sell it. One company charges $250 for making a master CD and designing the art for the cover. There is also a cost of $3 to burn each CD. The total cost, P of C, depends on the number of CDs C burned. Use the function rule 250 plus 3C to make a table of values and a graph. So if this is your company, you would make this quick little table and you could see right off the bat, oh, if I want to burn 200 CDs, it's going to cost me $850. So it's nice to just have those baseline numbers when you're running a company to see, oh, I have $1,000 to spend. I could look here and see, oh, then I can make about 250 CDs. So, another company charges $300 for making a master and designing the art, but it charges $250 for burning each CD. Use the function rule, make a table of values and a graph. So try that problem right here. All right, so I am going to do these same numbers. So I'm going to have C, I'm going to have my 100 CDs, 200 CDs, 300 CDs, 400 CDs. And then I'm going to do my P of C. So I would have 300 plus 2.5 times 100. So 300 plus 250 is $550. This one is 300 plus 2.5 times 200. So 2.5 times 200 is 500 plus 300 is 800. 300 plus 2.5 times 300. That is 750 plus 300 is 1050. And then 300 plus 2.5 times 400 is 1,000 plus 300 is 1,300. So then it says to make a graph. So I'm going to sketch a graph. and it's going to be all positive values. So like they did up here, I'm going to go by hundreds on the bottom. 100, 200, 300, 400. And then I'm going to just do this by 250. 250, 500, 750, 1,000. So 100 CDs cost $550, 200 is $800, 300 is $1,050, and 400 is $1,300. So it says your band decides to use the second company. You plan on making between 100 and 300 CDs. Find a reasonable range for this situation. So your reasonable range would be between 100 and 300. So you look at what your values are for 100 and 300. And then you say my range for my cost. So my range would be between $550 and $1,050. So that is your range. I can spend between that. All right, so here's two keywords, continuous data and discrete data. Continuous data is data where numbers between any two data values have meaning. Examples of continuous data include measurement of temperature, length, or weight. Use a solid line to indicate continuous data. So like back here, these would be continuous data because it's dollar amounts. So the number of CDs you choose, if I want to make 225 CDs, then it would be on there. Discrete data are data that involve a count of items, such as a number of people or number of cars, because you can't have anything in between a whole number, because it's a whole number car or a whole number person. You can't have a half. So that is for discrete data. So in some cases, like example 2, the scale of the graph makes it impractical to use a dot for each value. So like I was saying, you want to use a solid line because you want to include everything. So that is continuous data. So discrete and continuous. Determine whether the function rule models discrete or continuous data. Then make a table and graph each function. An automatic photo booth charges $3 for a sheet of photos. The function C of P equals 3P describes the cost of P sheets of photos. You cannot buy part of a sheet of a photo booth, so the data is discrete. Use points for each value. So then notice here that they just dotted. If I buy one sheet, it's $3. If I buy 2 sheets, it's $6. You can't buy 1.5 sheets. So that is discrete. So, graphing functions. You're going to see 2 new types of functions, the absolute value function and the x squared function. Now here are examples of each of their graphs. So what I think you should write in your notes is this: y equals the absolute value of x, and then write what the graph looks like. It is a V, because any value is always positive in absolute value. And these two, anything above this line right here, is positive on the y scale. So your answer is always going to be positive. If I put in a -2, I'm going to get out a positive answer. And then here, the function of an x squared looks like this. And this is a parabola. This is also very similar. It is going to be positive because anytime I square something, I end up with a positive answer. So, looks like this. So let's try these two, and then they're a little bit different than the other ones because they're subtracting where the other two were adding. So try these, make a table of values, and graph each function. Okay, so for my table, I'm just going to do -1, 0, and 1. And so then if I do the absolute value of -1, that's 1, minus 1 is 0. 0 minus 1 is -1. And 1 minus 1 is 0. And then if I make a graph, -1, 0 is here. 0, -1 is here. and 1, 0 is here. So this is going to look like this. Here I'm going to do the same thing, -1, 0, and 1. So -1 squared is 1, minus 1 is 0. 0 squared is 0, minus 1 is -1. And then 1 squared is 1, minus 1 is 0. Notice, look at both of these tables. They're the exact same. So if I ask you to graph these, which normally you're going to have a way more extensive problem than x squared minus 1. That's a very simple problem. But you're going to have to know the difference when you graph it. -1, 0, 0, -1, and 1, 0. The points are the exact same, but you need to know that this x squared forms a parabola. So when I graph this, it's not the straight lines. You need to know the difference between the two. All right, that is it for your notes.